Hi guys, I'm going to explain about the breast cancer prediction using machine learning and research algorithm. So it's a golden task of the CODERS data science internship program. So first, let's see about the outline of this presentation. So we will be seeing about the executive summary, introduction, methodology, conclusion, and finally the appendix, which contains the extra data about the project. Okay. So first, let's see the executive summary. So here I have mentioned that the data set is being collected from the Kaggle, and the data that we got is already pre-processed. So we doesn't have to do any wrangling techniques and pre-processing. So it's a neat data, and the major thing we have to do is only converting the category value into label encoders. That's the only thing we have to do in this data set. Then we have to apply the machine learning algorithm to predict whether the person is being affected by the cancer or not. Next, let's see about the introduction. Here, I have entitled the project to be BreastScan Pro AI-powered cancer prediction. So since it uses the artificial intelligence, the machine learning part to predict whether the person is being affected by the cancer or he or she may not be. So the main objective of this project is to understand the data pattern by means of the machine learning algorithms, which will be listed later. So using this, we have to identify the pattern and have to predict what will happen based on the criteria. And to implement a good algorithm with good results, accuracy, and reliability. Okay. Next, let's see the methodology. So first the data collection part. So the data set has been collected from the Kaggle itself. That is no other data set, which is collected from some other sources like warehouses, databases, and so on. Only it is being collected from Kaggle, where the link is being shown here. Next, let's see about the data wrangling. So it's a very important process in each and every process. Even though if it's analyzing process, it's a very important thing, and if it's a machine learning project, also it will be important. But over here, I haven't did any data wrangling process or the pre-processing works because the data is already pre-processed. The only thing I have did is the label encoding, as I said earlier. Okay. Then the algorithm that I have used to implement this and to find the best algorithm out of the 4 algorithms. So first I have you implemented the gridset CV. So here this gridset CV is capable of diagnosing each and every of these 4 models: the decision tree classifier, extra tree classifier, logistic regression, and MLP classifier. So over these 4 algorithms, it will combine together and it will train the model for the particular data set with some hyperparameter that I have given. So it will search for each and every possible task and it will return the best parameters as well as the best model with the best results. So by means of that, we can easily choose the best model with the best hyperparameter and can implement to get a good accuracy as well as good reliability. So next I have implemented the addition tree classifier, which is a base algorithm. So here this classifier implements the classification of each and every type. So consider a situation if you are having some reasonables like where the person is being having some age below 20 or greater than 20. So in that case, it will classify a tree for that. Like a node will be the answer if it's true, if the condition is true, and another node will be the answer if the condition gets failed. So by this means this decision tree classifier performs. Okay. Next, the extra tree classifier. So it's an upgraded version of the decision tree classifier with random forest classifier. Okay. So it reduces the underfitting, which is a biased form in which the decision tree classifier mainly occurs. So this avoids the overfitting as well as the underfitting. So by means of this extra tree classifier, we can make somewhat better observation. Also the classes as well as the reasonables, the values are being chosen at random state. So we can get a non-biased solution. Then the logistic regression. So logistic regression is an algorithm which is used for classification as well as the regression problem. So it is only used for binary classification. Other than the binary classification, there's a classification which is called as multi-class classification, which is not too much reliability in this logistic regression because it takes a sigmoid function to get a result. So which is only good for the binary classification. And finally the MLP classifier. So it's an artificial neural network. MLP stands for multi-layer perceptron classifier. So perceptron is a node. Okay, so multi-layer stands for the multiple layers of nodes will be presented over here. Next, result. It's the most important thing in each and every project. And let's see. So here, this plot is called as a confusion matrix. So it will display whether the model is predicted good or not good. So over here, we should know about two terms. So benign and malignant. So benign means it's like the person is not being affected by the cancer. Malignant means the person is being affected. Okay. So over here, the y-axis, so the over here in this plot, the confusion matrix, the y-axis shows the actual values and x-axis shows the predicted value. Okay. In the test case, over 72 data are being benign, which is the actual one. But our model prediction is like 70 are being classified correctly and 2 are classified wrongly. So which is you can see over the confusion matrix. Okay, then similarly for malignant there are around 42 data, but our model classified wrongly 4 as well as correctly as 38 counts. Okay, so but it's a test data, it is not being used to train the data. It's an entirely new type of data which is being classified with the help of train test split of scikit-learn. Next, conclusion. So we found that a decision tree classifier is the best tuned algorithm for our particular use case, like the classification of the breast cancers. So this model with the tuned hyperparameters with the help of Gritzer CV has been used to get a better and higher results. And finally, we got the accuracy of around 94%. So we can trust the model for around 94%. So this is the appendix where you can see the project notebook file, which is the Jupyter notebook file. You can see this. And finally, thank you.